So this section talks about combining functions. We want to learn how to combine functions arithmetically. Okay, come on, highlighter. We want to compose functions, and we want to decompose functions, so break them apart. Okay, so let's start out with the definition. Let f and g be two functions. The sum f plus g, the difference f minus g, the product f times g, and quotient f over g are four new functions defined as follows. F plus g of x equals f of x plus g of x. F minus g of x equals f of x minus g of x. F times g of x equals f of x times g of x. And f over g of x equals f of x over g of x, provided that g of x doesn't equal 0, because we cannot divide by 0, right? Dividing by 0 is illegal here. So these are the rules of the game for right now. So now the facts here, we need to know the domain. So remember, your domain you associate with the x values of a function. The domain of f plus g, f minus g, and f times g consists of the common elements or intersection of elements. So what those two functions have in common of the domains of f and g individually. Okay? The domain of f over g consists of the common elements of the domains of f and g individually, but throwing out the elements for which g of x equals 0. So if we get 0 in a denominator, if -2, for example, gives us 0 in the denominator, then we have to exclude -2 from the domain of f over g. Okay? So, for 1 second, the domain of f over g consists of the common elements of the domains of f and g individually, omitting the elements for which g of x equals 0. Let's look at an example. Did everyone have that from the previous page? Mm-hmm. Okay. So given f of x equals the cubed root, this is how we say it. F of x equals the cubed root of x, and g of x equals x minus 1. Let's find f plus g of -1 in part A. So here we're finding the sum evaluated at -1. So by our rule, that is equal to f of -1 plus g of -1. Our operation is addition, right? We're not multiplying here. So we need to find f of -1. We need to find f of -1. So which function do we use, f of x or g of x? F of x, good. So this first part means we take -1 and substitute it into f of x to get the cube root of -1. Plus, what do we do now?
-1 and -1.
Good. And we're going to put that in parentheses. Technically, we don't have to do that here with the parentheses because the sign in front is addition, but we have to be careful in case that's subtraction. So I'm just putting it here for good habits. Okay? So now, what's the cube root of -1? -1. Good. -1. -1 minus 1 is?
-2.
I heard 3 answers for my question is what -1 minus 1 is? -2. Good. So this is -2. -1 minus 1 is? -1 minus 2 is?
-3.
-3. Good. So that's our final answer. Would you like a second to try B?
Yeah.
Oh, there's a question? What question do you have?
Oh, never mind. I was gonna ask you, how to get rid of the cube, but I see it right there.
Because the cube root of -1 is 1. So -1, so an aside, that's a good question. So an aside, -1 to the third power is equal to -1, right? So whenever we take the cube root of -1 to the third power, that cube root cancels out with that 3 technically, and you get -1. Good question. What other questions do you have about A? Okay, go ahead and take a minute to do B. Very good. You got 1. So let's write it out. Let's justify. So this is the same thing as f of -1 minus g of -1. So this is equal to f of -1 is the cubed root of -1 minus g of -1. G of -1 is -1 minus 1. And you don't have to rewrite this again. You already found f of -1 and g of -1 in part A, so you can use that throughout the remainder of the problem. Does that make sense?
Yes.
Okay. So we know this is now going to be, is there a question?
No.
Okay. -1 minus -2, which is the same thing as -1 plus 2, which is 1, as you said. What questions do you have? Okay. Good. So part C. Part C, we want to find f times g of -1. So how do we rewrite it initially?
F of -1
Times G of -1.
Times g of -1. Good. We know, so let's just write out on the side what we found already. We know f of -1 is going to be -1. We already know g of -1 is what? -2. Good. So we're using that to help us now, right? So f of -1 we said is -1. And then g of -1 we said was what? Good. So -1 times -2 is? +2. Good. What questions do you have? Find D. Find D. I'll give you a minute. Part D, you had to find f over g of -1. What did you get?
1/2.
Very good. So that's equal to f of -1 over g of -1. We know f of -1 is -1, g of -1 was -2. So simplifying that, we get 1/2. Okay? All right. So now we talked about domain on the first page. So now let's do an example. Yes, go.
I have a question.
Sure.
I actually divided them, but I didn't put them as a decimal. I mean,
What do
I
you-
put them as a decimal. Like I had,
0.5.
yeah, 0.5. So if I put them on the test, will it be wrong?
So I will be very specific. If I don't want decimal representation, I will say that.
Okay.
I will say that. I typically prefer for you to leave it in fraction format, but if decimals are allowed, that will say it. I typically have those in the instructions at the top of the page for the exam. Good question. What other questions do you have? Okay. All right. So we talked about domains on the beginning, or at the beginning on page 1. So now let's actually apply it. So given f of x equals x squared minus 1 and g of x equals the cube root of x, in my head, I'm already thinking about the graphs of them, right? Because you know what they are. X squared minus 1 is the shape of a what? Parabola. And what do you do with that parabola?
Shift it to the right.
I heard shifted left. I heard it shifted right. Down. 1, right? Because that minus 1 is on the outside. So make sure you're reviewing your rules daily for shifting because that's important. You're going to see that often. So make sure you're reviewing that. So the graph of x squared minus 1, this is a new problem, right? X squared minus 1 looks like that. And then the cubed root of x looks like what? We talked about parent functions in their graphs before. What was the cubed root of x? What did it look like? Go ahead.
I'll lie.
That's right. That's right. It is laying on the side like this. Good. I see you drawing it in the air. Very good. Very good. So I'm sure whenever you're taking your exam, I'm going to see arms everywhere now because we did that in class. Very good. Okay. So now all of that so we can just identify what's happening. So we want to find the formula and the domain for f plus g. So first we want to find the formula. So in other words, let's just write out what f plus g of x is. So f plus g of x is f of x plus g of x. And typically you don't have to write this at all, right? I'm just writing it because you're just learning it. So that's equal to x squared minus 1 plus the cube root of x. That's the formula. That's it. That's the formula portion. Okay, so we found the formula. And now we need to find our what? Domain. You got it. So the domain for f plus g, let's take a minute to think about it. The domain for f plus g, remember, is all the x values they have in common, right? So what's the domain of x squared minus 1? Excellent. It's all real numbers. And we write that, so I'm going to zoom out a little bit. So we know, as you said, the domain here for x squared minus 1 is all real numbers. What's the domain for the cube root of x? Very good. So then I'm going to ask you, what's the domain of the sum? All real numbers. Good, because it's what they have in common. Go for it.
Is like negative to infinity equivalent to all real numbers?
Absolutely. So in interval notation, negative infinity to infinity is the same thing as all real numbers.
Okay, so
You got it.
If we were to like do that, can we put negative infinity to infinity for domain?
Absolutely. That's perfectly fine. Or negative infinity to infinity. Yes, you can. What other questions do you have? Okay, good. So now let's find the formula and domain for f over g. So tell me what the formula is going to be for f over g of x.
X squared minus 1 over the cube root of x.
You got it. Good. That's it. So this is our formula. That's our formula. Okay. And then the question is going to be, what is our domain here? Is it the same idea as in part A now? Or did it change? I see yeses. It's the same idea? How is it the same idea?
Because it's still the same. Your graph doesn't change, right?
Your graph doesn't change. That's true. So we still know the domain of f of x is all real numbers. We know the domain of g of x is all real numbers. But let's go back. Did we take all of that into account?
No.
What do we have to take into account now?
Zero being in the at the bottom.
At the bottom, right? In the denominator, or in g of x, as you said. Good.
So 0 consists of all real numbers?
The 0 consists of all the real numbers? What do you mean? What do you mean?
Like she's saying, is it included in the all real numbers? Like
0's included in the real numbers.
Okay.
Zeros included in the real numbers. Mm-hmm.
What?
So can 0 be included in our domain?
No.
No.
Why
Because
not?
the rules said omitting 0. You gotta.
For
Did it say omit 0?
No,
What did it say?
Not even
Make elements for which g of x equals 0.
You have to throw out the elements for which g of x equals 0. Right?
F of x
And say it again.
F of x can equal 0.
F of x can equal 0, but whenever we're dividing by g of x cannot be equal to 0. Okay, so let's be clear. What that rule says is whenever you look at a quotient, whatever you're dividing by cannot be equal to 0. So in particular, we know the cube root of x cannot be equal to 0. And what makes the cube root of x 0? 0. Very good. 0. So that means x cannot equal 0. Right? So then we have to figure out how to write in interval notation all real numbers excluding 0.
Oh, it's the okay, it's like parentheses, negative infinity, comma, 0, parentheses,
And then the union.
and then the union, parentheses, 0, comma, positive infinity,
Mm-hmm.
parentheses.
You got it.
Yeah.
Good.
Period.
Good stuff.
She hated that.
That's it. So that's our domain.
See, 'cause
That's our domain.
interval notation.
And you can use interval notation if you prefer it, right?
I can never I feel like I can get domain and range visually, but putting in the interval notations will mess me up for some reason.
So that's whenever you practice, because the visual representation with your graph makes more sense.
Yeah.
Then it's going to be helpful for you to actually put the graph down and then go through and figure out or highlight the x values that correspond to that and then put that in interval notation. It may require a step in between, but that's okay. As long as you get there is the most important part. Okay? All right. So let f and g be two functions. The composition so we think of a music composition, putting things inside of each other, that type of idea. Okay? Let f and g be two functions. The composition of f and g, denoted as f circle g, is the function defined by f circle g of x is equal to f of g of x. So you're taking g of x and putting it inside of f.
It's like fog.
There, fog. People remember this as fog and golf. Okay? Good. The domain of f composed with g consists of all x in the domain of g for which g of x is in the domain of f. What the heck?
I don't know what that is.
What the heck? Let's put a picture with it, okay? So, if we start out with an element x over here, then whenever we are finding, come on and highlight, f composed with g of x, then that means we take x, we use our function g, x first goes into g, so that will map to or go to the element g of x. And then using f, the function would go to, or the element g of x would go to f of, you got it. And so whenever we look at this overall, from there to there, that's called f composed with g. And the black one was f. Okay? So think of, do you all remember those like cheese and crackers with the little red stick in them? Okay, so think about that for a second, right? If you want to make a cheese sandwich, you have to put your cracker down first, right? And then you have to put the cheese on top of that cracker, and then you have to put the other cracker on top if you want a cheese sandwich. Or if you just want a cracker with cheese on top, the little snacks.
Yeah.
Yeah. But what is the idea, the process of making that is the same idea as this function composition.
So like layering.
Yes, it's layering,
Okay.
but one is going in the other.
Okay.
Yeah, that's right. Okay, so let's look at an example to see how this is done algebraically. So in each of the following, find f composed with g of 3. So this is what we're finding. We're finding f of g of 3. That's what we're finding in each one. We have different functions. We have different elements. So f of pi is equal to pi squared. G of 3 is equal to pi. So we want to find f of g of 3. What's g of 3?
Pi.
Pi. Good. So we're finding f of pi, right? So g of 3, we put here. That's how we got pi. And then we find f of pi. And what is f of pi?
Pi
Pi
squared.
squared.
Pi squared. So that's our final answer.
Wait,
So, want me to explain again?
one more time.
One more time. F of g of 3. We good there? First we take 3, put it into g to see what we get. G of 3 is equal to pi. So that's here. G of 3 is equal to pi. So now we have to find f of pi. We know that f of pi is equal to pi squared. That's how we got pi squared.
So essentially, we already have the answer. We just have to put it. Okay.
You have to show how you got it.
We just gonna plug and play.
Plug and play. You can look at it like that, but I started out with an example where I've given you the stuff without you having to actually do a different kind of computation. This next example involves a computation, but it helps to see what's being done first and how you apply it, and then actually get your hands dirty a little bit. Does that make sense? Are we good? Okay, so B, we have f of x equals the square root of x squared minus 9, and g of x equals 1 minus 2x. So our goal is still the same. We have different functions in this problem. So we have to find f of g of 3. We need to find g of 3. So an aside. G of 3, we have to use g of x, right? So g of 3 is going to be 1 minus 2 times 3, good. So that's equal to 1 minus 6, good, which is good. So this is f of what? Negative 5, good. And then we have to find out what f of negative 5 is. So now we take negative 5 and put it where?
In the square root.
In the square root.
You got it. So the square root of?
Negative 5 squared.
Good. All of that minus? Good. Square root of, or the negative 5 quantity squared is what?
25.
Good. 25, bless you. 25 minus 9 is? 16. Good. And what's the square root of 16?
4.
Yes. Very good. That's it. That's it. Okay. So I will finish recording this video, and then I'll post the video, and then I will most likely open your quiz on Tuesday. All right?
Homework for 5.3, will it remain the same as due Sunday, or would you extend it since we did?
I'm going to move it because it's a holiday.
Okay.
I'm going for the homework for this. Everything that was due by the 28th is still due, but for the homework for this, I'm going to move it because I didn't finish it, and I want you to be able to finish watching it.
Okay.
All right. Have a great. We ended class by talking about this following example, which is the composition of functions f composed with g evaluated at 3. So we found f of g of 3 in both cases with different functions f and g. Okay. Now we're going to continue with that, and we're going to do example 4. Example 4 says, given f of x is equal to 4x minus 2 over 3 and g of x equals 1 over x, A, we're going to find the formula and domain for f composed with g, and B, we're going to find the formula and domain for g composed with f. So let's go ahead and find the formula for f composed with g. So remember, f composed with g of x looks like so. What do we do first? Find g of x. What's g of x? Very good. So we have to find f of 1 over x. Okay? So now with the 1 over x, we take this 1 over x and now we put it into f of x for that x. So we're going to highlight this x there because that's where we're now putting 1 over x. So this is equal to four times 1 over x minus 2 all over 3. And we can simplify, making this a little bit more nice. And so this becomes 4 over x minus 2, all of that over 3. And you may want to eliminate this rational function here, 4 over x. And the way we do that is we multiply this entire function here by 1 in the form of x over x. So we're going to multiply this. We're going to have 4 over x minus 2, good morning, over 3. And we're going to multiply that by x over x. And we're doing that. We're not changing the equation. We're multiplying by 1. And then what we're going to do is we're going to eliminate that fraction or rational part in the numerator. So this is going to give us, what's 4 over x? You want me to write the step before it's simplified? Okay. So this is 4 over x times x minus 2 times what? Good. All over 3 times x. Good. So these x's here cancel out, and that leaves us with 4x minus 2x all over 3x. And wait a minute, is that 4x? It's 4, right? It's 4. So that should be 4, not 4x. That should be 4 because the x is canceled out. So you have 4 minus 2x all over 3x. Okay? So this is our formula. This is the first part of our answer. That's the formula for f composed with g. And now we need to find the domain for f composed with g. Now the domain of f composed with g is the set of all numbers where g of x is not equal to what? It's the set of all numbers. Yes. Where your is it x can't equal 0 or your denominator cannot equal 0? Ah, good. So your denominator cannot equal 0. So our domain, what makes our denominator 0? Wait a minute. So you're telling me all real numbers make this denominator 0? So we could put in 3. If we put in 3, does that make our denominator 0? No. What makes our denominator 0?
0.
0. So our domain would be all real numbers except for 0. And we need to put that in interval notation. Very good. So this would be negative infinity to 0. What goes in between? Union. Good. 0 to infinity. That's your domain. Those are the two parts. Okay? So now we want to find the formula and the domain for g composed with f. Same flavor, just we're doing G composed with F instead of F composed with G. So now we're finding G composed with F of X. What do we put in first? 4x minus 2 over 3. Very good. So you're finding G of 4x minus 2 over 3. Now tell me what we do. Now what do we do? You put that into G of X. Very good. So now we're taking this 4x minus 2 and we're putting it into G of X where we see an X. Does that make sense?
Yeah.
Okay, so that's what we're doing now. Good morning. So this is equal to 1 over 4x minus 2 over what?
Over 3.
Got it. Very good. And whenever you simplify that, what do you get?
4x minus 2 over 3.
You have 1 over 4x minus 2 over 3. So whenever you have 1 over a fraction, what does that become? Not a decimal. If you put 1 over a number, yes, that could be equivalent to a decimal. But here we have a formula. We have 1 over 4x minus 2 over 3. So if you need to send a message, go out in the hallway. We have 1 over 4x minus 2 over 3. So whenever you have 1 over 4x minus 2 over 3, if you're dividing 1 over a fraction, what does that simplify to become? The 1 times you leave your numerator fixed and then you multiply by the reciprocal of your denominator. Very good, the two of you. So this would be 1 times, what's the reciprocal of our denominator?
3 over 4x minus 2.
Very good. So that simplifies to give us 3 over 4x minus 2. So then the question is, what is your domain? So this is part of the function. This is your formula for G composed with F. And let me separate parts A and B. So that's the formula for G composed with F of X. Okay? So how do we find our domain? Set the denominator equal to 0. Good. So let's set the denominator equal to 0. We get 4x minus 2 equals 0. I'll move that up a little bit higher. We get 4x minus 2 equals 0, not divided by, equals 0. So now we're trying to find out what our domain is going to be. So what is our domain? So yes, that's absolutely correct. 4x equals 2 or x equals 2 over 4. 2 over 4 is the same thing as what? 1/2. So 1/2 will make our denominator 0. So what is our domain in interval notation?
Negative infinity.
To 1/2. What goes at 1/2? Parentheses or bracket? Very good. That's right. Very good. Because it does not include it. You got it. And what goes in between?
Union.
Good.
And then 1/2.
What goes at 1/2? Good. Good.
1/2, comma, positive.
You got it. Good. All of you. Good. So this is our domain. Okay? So it's important. Notice that we found a formula first, right? And once we found a formula, we then found a domain. So it's helpful to know what your function is. Okay? What questions do you have? Good morning. Okay? So decomposing functions is our last one. So I started out examples 3 and 4 by giving you 2 specific functions. But I can give you a function like part A, where you have f of x equals 2 over 5x minus 1, an example 5, and I can ask you, how do you decompose that function? So in other words, I'm asking you now, what are the 2 original functions? Okay? it's not unique. Some of you may come up with two different functions, but the important thing is to make sure the composition ends up to be the same. Okay? So, part A, we have f of x equals 2 over 5x minus 1. And we want to find out what two functions we had, g of x. Do you want to use f composed with g of x? Do you want to keep f and g, or is it okay to use different variables? You want to keep the same too? So I'm going to call this h of x then. I'm going to call that h of x. So I'm asking you, what is f of x and what is g of x? What two functions and what composition f of g of x would give you h of x? What combination? That's what I'm asking. What composition? So, what would f of x be? 2 over x. Very good. And what would g of x be? 5x minus 1. Good. As Lisa said, it's 5x minus 1. So let's make sure we understand what we're doing. Okay? So we need to identify two functions such that when we compose them as f composed with g of x, we get this function back. So, just to check, if we're looking at using our two functions that we came up with, if we're using that, f of g of x is equal to f of what? What's g of x?
2 over x.
What's g of x? 5x minus 1. Good to both of you. And f of 5x minus 1 means we need to take 5x minus 1 and put it in for what?
For f of x.
Put it into x for f of x. Good. Excuse me? So whenever we find f of 5x minus 1, this 5x minus 1 is not what we're plugging into. This 5x minus 1 is what we're plugging into x here in our function f. So that means we now have 2. Good morning. We now have 2 over what? 5x minus 1. Good. Over 5x minus 1. And that's it. So that's how we were able to come up with the two functions f of x and g of x. Okay? Remember, if you need to send a message, go in the hallway. Okay? So now, since you like f and g, in part B, I'm going to call that function h of x now. So h of x is equal to the absolute value of x cubed minus 5x, all of that plus 7. Take a minute, discuss it with your neighbors, and tell me what f of x is going to be. Tell me what g of x is going to be in order for us to get h of x when we compose f of g of x. We want f of g of x to be h of x. I'll give you 1 minute. What's f of x? You said x plus 7? X plus 7? What's, I can't hear you. What's g of x?
X to the power of 3 minus 5x.
X cubed minus 5x? Everybody agrees?
I don't know. I didn't explain it.
I'm asking.
Oh, I don't know. I didn't accept it. I'm not gonna lie, I was confused.
What? You had a whole over a minute. Okay, so let's check this. You're saying now go back and put absolute value where? Around x cubed minus 5x. Let's check it with what you told me initially, and then if that's not correct, let's go back and make the adjustment that you suggested. Okay, so we're checking right now. think of how would you, so just thought process wise, what are we doing? If somebody gives you a puzzle put together, then your goal, you want to undo the puzzle and figure out how to put it together yourself. Right? So here, I've given you a puzzle put together, which is your function, and I'm asking, how do you take it apart and figure out how to put it back together with only 2 parts? That's the thought process. Okay? So here, if we're checking, we would put in g of x first. So we would have f of x cubed minus 5x. So now that means whenever we substitute in x cubed minus 5x here, hopefully we'll get this. If we don't, that means we need to go back and make an adjustment. So now this would be, we're now putting it in for x in f of x, so that gives us x cubed minus 5x, all of that plus 7. Is that equivalent to h of x?
Yeah.
This is the same thing as this?
Because it's missing the absolute value
It's
sign.
missing the absolute value sign. So we do need to go back in and make an adjustment
Should you
And
just put an absolute value sign on
around what?
G of x? No,
You-
wait, I lied. Don't listen to
Yeah.
You
the?
can
Yeah, just G of X, yeah.
g of x, and I see somebody saying, oh, because there's another way to do it too. This is one way. This is one way, which will then give you this answer, right? It'll give you exactly what you want. Or you can say, take f of x to be the absolute value of x plus 7 and leave g of x as equal at being equal to x cubed minus 5x. There are a couple of ways you can do this one. Okay?
But the first one is the easiest.
Nope, there's no easiest. They're different ways. They're different ways. It's a good question. They're different ways of doing it. So there's not a unique way of doing it. It depends on your thought process. But as long as it's algebraically correct, that's fine. What other questions do you all have? Okay, good. This is combining functions. This is section 5.3. Okay? This is section 5.3.